In this video, I'm going to talk about graphs of rational functions. We talked about graphs of rational functions already before, and we talked about the steps to graphing rational functions, but we didn't talk about slant asymptotes. So this is lesson 2.7 part 2, and we're just going to talk about slant asymptotes. So that will be the topic of this video. If I have a rational function, f of x, I know I have some polynomial over another polynomial, and we referenced it before as n of x as the polynomial on top and d of x as the polynomial on the bottom. And we know that what we're concerned mostly about, or what we're concerned about when we're looking for the horizontal asymptote is the highest power in the numerator and the highest power in the denominator, and we compare them. And sometimes we don't have a horizontal asymptote, and for those cases, that means we have a higher power in the top than we do in the bottom. So, for example, if I had ax to the nth power plus ... that was the highest power in the numerator, and I had, actually, you know what, I don't need the a, it's fine. If I had x to the nth power plus ... in the numerator, and x to the nth power plus ... in the denominator, and the nth power was the highest degree in the top, and the mth power was the highest degree in the bottom, then I would know that if n was greater than m, I would not have a horizontal asymptote. So when I don't have a horizontal asymptote to describe the end behavior of a rational function, I'm going to look for if there's a slant asymptote, because there might be a slant asymptote instead in that case. And that will be, if n is equal to m plus 1, there will be a slant asymptote. So if the numerator power is 1 higher than the denominator power, then the graph has a slant asymptote. And that slant asymptote is going to be at q of x, which is the quotient stands for the quotient from dividing the top by the bottom of the fraction for the rational function. So to find what the slant asymptote is, a slant asymptote is a diagonal line. I know it's going to be in the form y equals mx plus b. I'm going to divide the top and the bottom, and I'm going to get a line. So for example, let's try an example. If I want to graph f of x is equal to x squared over x minus 2, if I wanted to graph this, the first thing that I'm looking for, or the first thing I want to try to do is factor that thing, and I can't factor it, so I leave it the same. There's nothing that cancels in the top and the bottom. You might want to cancel an x. You might feel like you want to do that, but don't do that because you can't do that. Because of the subtraction that is in the bottom. So for holes, there are none. There are no holes. Then I'm looking for vertical asymptotes. I have a vertical asymptote in the denominator. There's an x value that makes that denominator equal to 0, and that's 2. So I have a vertical asymptote as x is equal to 2. And then I'm looking for my horizontal asymptote. I have x squared over x to the first power. Those are the highest powers. I have a numerator power greater than the denominator, so there is no horizontal asymptote. So now this is where I need to look for if there's a slant asymptote. So for a slant asymptote, and eventually I'm just going to call it SA, but this is the first time we're talking about it, so I'm going to actually write out slant asymptote. For my slant asymptote, what I'm going to do off to the side is I'm going to do long division. I'm going to divide the top by the bottom here. So I'm going to do x squared divided by x minus 2. X squared, what I put inside, or when I'm doing long division, I want to include all powers from the highest power down to the lowest power. So Right now I have x to the second power, but I don't have an x term. Sorry. I want to start with the highest power and I want to go down to the constant. Right now I'm missing the first power and I'm missing the constant. I have x squared, so I want to add 0x and 0 so that I have placeholders for my x to the first power and my constant. It's just going to make my life a lot easier if I do that. Now that I've set this up and I have my highest power down to my constant inside of that long division bar, I am going to divide. So I'm looking at this x that I have as from the thing that I'm dividing, and I'm looking at what I would have to multiply that by. So what would I have to multiply that by to get x squared? And I would have to multiply it by x. I would have to multiply it by x to get x squared. Then what I'm going to do after I put that x up here is I'm going to do what I would do if this was a number. I'm going to multiply my x minus 2 by that, and then subtract it from this polynomial that I have. So I multiply x times x to get x squared. I multiply x times negative 2 to get minus 2x. I am taking this expression and I'm subtracting it. So I'm taking it away from the polynomial that I have to see what I have left over to take care of. And so when I do that, I'm going to end up with my x squared minus x squared goes away because that equals 0, which is what I tried to do. And then I have 0x minus negative 2x. Be careful, if you're subtracting a negative, you're actually adding. So that's adding 2x. I'm going to get 2x. And I'm going to bring that down, that plus 0 down. Now I'm going back and I'm asking myself, what do I have to multiply x by to get 2x? And I have to multiply x by 2 to get 2x. So I'm going to add 2 up here. Then I'm going to multiply 2 times x and 2 times negative 2. And that's whatever I get. When I do that multiplication, I'm going to subtract from what I have left over to see what I have left over after that. So 2 times x gives me 2x. 2 times negative 2 gives me negative 4. And I'm going to subtract that and see what I get. And when I subtract, I'm going to end up with 0. This goes away. 0 minus negative 4, which is 4. And I can't fit this into there, so I stop, and that's my remainder. All I care about, so what I would actually write as the answer for this is, of this division is x plus 2 plus 4 over x minus 2, because I can't actually divide, I can't fit x minus 2 into 4. Well, I can't fit x minus 2 into 4, so 4 is my remainder. I put that remainder over what I was dividing by and add it to what I have on the top here. And so what I'm looking for the slant asymptote is just a line. I don't care about the remainder, so I'm just going to get rid of the remainder and I'm not even going to look at it. I'm just focusing in on this x plus 2. So my slant asymptote is going to be y equals x plus 2. That's my slant asymptote here. Also, what I look for is my y-intercept. So my y-intercept here in this example, I'm plugging in 0. I'm going to get 0 in the numerator, so it's 0, 0. And then my x-intercept is also 0, 0, and that's the only thing that would make the numerator 0, so that's it. And then I graph this. So I'm going to draw a graph. Oops. I'm going to erase this, or actually, I'll just move it. I'll move it over here. Okay, and then I'm going to graph this. So, all right. First, I'm going to graph my vertical asymptote. So I have a vertical asymptote at x is equal to 2, right here. At x equals to 2. And then I usually would put my horizontal asymptote in, but I don't have one of those, so I'm going to put in the slant asymptote. next instead. That slant asymptote, I start at 2. And then I have a slope of 1 over 1. So I go up 1 to the right 1, 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 up 1 to the right 1. And if I go to the left of this point, I'm going down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. And I'm going to just put it as points for myself. And if you want to, you can put in the dashes. But if you just leave it as like a pointed line, then I'm okay with that. For your slant asymptote, but that is my slant asymptote. So this is just a diagonal line. Then I put in my important point, the other point that I have, which is 0, 0. And now I'm going to plot the rest of this graph. I know as I go to, or I can always check points. If I don't know what this is going to look like, I can check points. So that's what I'm going to do here. I'm going to check points. I'm going to plug into the function. I'm going to plug in x's, something to the left of this important point that I have. So I can see what the shape is going to look like here, if I couldn't tell. If I plug in x is -1, which is to the left, I'm going to get, so f of -1 would be -1 squared, which is 1, over -1 minus 2, which is -3. So I'd get -1/3, which means that I am going to be going downwards, which makes sense because as I go to the left, my end behavior is described by that slant asymptote. So as I go to the left and keep going to the left to -infinity for x, I should be getting closer and closer to that slant asymptote. So it makes sense that I would be going downwards from this important point that I had. As I go to the right at that point, I can check what is it going to look like. And I'm going to plug in a value to the right, so plug in 1. If I plug in 1, I'm going to have f of 1, and that's equal to, I have 1 squared in the numerator, which is 1, over 1 minus 2, that's -1 in the denominator, so that's -1. So I have 1 and -1 right here. So with the point 1 comma -1, I see that I should be going downwards to the right, and then as I go more to the right, I can plug in more points, as many points as I want. I'm going to see that I'm getting closer and closer to that vertical asymptote. If I see a piece of my function in the bottom left, I should see a piece of my function in the top right as well, but I'm going to just check to see that that is what I see. So I always want to check just to make sure, because sometimes, or if I'm ever unsure of where the other piece is going to be, and it's always just best to check. You have a lot of time on your test, so please check points just to make sure, even if you are like 99.9% sure you're right. Even if you're 100% sure you're right. So I'm going to plug in something to the right of that vertical asymptote. So I'll plug in x is 3. So if I plug in f of 3, I'm going to get, I have 3 squared, which is 9, over 3 minus 2, which is 1. So I'm going to get 3 and 9. So I'll be at 3 and 9, which is up here-ish. That's probably not right. I didn't count. And then I know that I have a piece, that looks like this up there. I should erase this vertical asymptote to be less confusing. So I have a piece that looks like that. Okay. All right, and then let's do another example. So for another example, let's do f of x is equal to 2 plus 3x minus x squared all over 1 plus x. For this, I am going to, first of all, I'm going to reorganize this so that I have my x squared first, and I have highest power down to the lowest power. So I'm going to write negative x squared plus 3x plus 2 to make my life easier, because that's how I'm used to looking at this. And then I'm going to change this to x plus 1. I'm going to take out a -1 in the top and see if there's anything that I can factor. I have then -1 times x squared minus 3x minus 2 all over x plus 1, and then I'm looking if there's anything that I can factor this to be, I need two things that multiply to -2 and add up to -3. And I can't think of anything that does that. So I can't actually factor that thing. I just wanted to check if I'd be able to cancel with the denominator, but I can't. Okay, so that means since there's nothing that I can cancel, there is no holes here. So for holes, I put none. The next thing I'm looking for is if I have a vertical asymptote. So if I have a vertical asymptote, that means, or that's an x value that would make the denominator equal to 0, and I have one of those. Its x is -1. So I have a vertical asymptote at x is equal to -1. Then I'm going to plug in, or I'm going to look for horizontal asymptote. So I'm comparing the highest power in the numerator and the highest power in the denominator. I have x squared and x to the first power. That is, I have a higher power in the numerator than the denominator. This fraction is top heavy, which means that I do not have a horizontal asymptote. So there is none. And then, so since there is none, there's no horizontal asymptote, I'm looking to see if there is a slant asymptote. And so I'm looking for the slant asymptote by dividing the top and the bottom. So I'm going to use this version. Off to the side, I'm going to do -x squared plus 3x plus 2 divided by x plus 1. And I've included every power from 2 down to the constant. So I have x to the second power, x to the first power, and my constant. So I'm good, and now I can start dividing. I'm looking for what do I have to multiply x by to get -x squared, and I put that here. That is -x. So x times -x gives me -x squared. Then I multiply this by both terms that I have here. So -x times x is -x squared, -x times 1 is -x. And I'm taking this expression and I'm subtracting it from the polynomial I have to see what I have left over. 3, this cancels out, that's what I intended to do. And then I have 3x minus -x, which is 3x plus x, or 4x. Now I bring down the 2. I ask myself, what do I have to multiply? What do I have to multiply x by to get 4x? And that is 4. So I'm adding 4 here. X times 4 gives me 4x. So I multiply 4 times x, and then I multiply 4 times 1. So 4 times x gives me 4x. 4 times 1 gives me 4. I am subtracting this from that. I don't really need to do anything else because I don't care about my remainder. I can just stop there and say this is my line. Y equals -x plus 4. So my slant asymptote, the line is y equals -x plus 4. So that's my slant asymptote, and then I'm looking for my y-intercept. My y-intercept in this case, when I plug in x is equal to 0, I'm going to get 0, 2. And then if I wanted to look for what my x-intercept was, I would have to use the quadratic formula to do that. So I would, whoopsies, that's not the right equation. So I have -x squared plus 3x plus 2 when that is equal to 0. I'm solving for what x would be, because that's what's in the numerator. And then I'm doing x is equal to -b, which is -3, plus or minus the square root of b squared, which is 3 squared, or 9, minus 4ac, that's 4 times -1 times 2, all over 2 times -1, because 2a. Okay, and then I get x is equal to -3 plus or minus the square root of, I have 9 plus 2, because I have, 9 plus 8, which is 17, all over -2, and then the square root of 17 is, I don't know, let's use a calculator for this. Anyways, I'm going to get this is 3.56, or so x is 3.56 about, or x is negative 0.56. So those are going to be my two x-intercepts. So 3.56, comma 0, and negative 0.56, comma 0. And then I'm going to make my graph. So now I have all my important information. Oh my God. Now I have all my important information, and I'm going to plot these points. So I have 0, comma 2. I have 3.56, comma 0. I have negative 0.5, comma 0. And then my vertical asymptote, oopsies. My vertical asymptote is at x is negative 1, right here. And my slant asymptote I'm going to draw is, it starts at 4, so right here. And then I have a slope of negative 1 over 1. So I'm going down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And I keep doing that. And then to go backwards, I go up 1 to the left 1, up 1 to the left 1, and I keep doing that. And then I turn this into a dashed line. And then from there, I am going to graph. So here in this area here, I should see that as I go to the left, I'm getting closer and closer to that vertical asymptote. And then I should see as I go to the right, I'm getting closer and closer to that slant asymptote. So that's what that piece should look like. And then I know if I have a piece in the bottom right, I should have a piece in the top left. But I can check a point just to make sure. So I'll plug in, whoopsies. I'll plug in x is something to the left of the vertical asymptote, so negative 2. If I plug in x is negative 2, I'm going to get f of negative 2 is 2 plus 3 times negative 2 minus negative 2 squared, which is 4, all over 1 plus negative 2, which is negative 1. So that's 2 plus negative 6, which is negative 4, minus 4, which is negative 8 divided by negative 1, or 8. So I should be at negative 2, comma 8. 1, 2, 3, 4, 5, 6. I counted wrong. 1, 2, 3, 4, 5, 6, 7, 8. I think that's right. And then I know that this piece is going to look like this. And I can check more points if I was confused, but that's what that piece is going to look like. And then let's do one more example. So example 3, I'm going to do f of x is equal to x squared plus 3x minus 4 all over x minus 1. And here what I'm going to see is when I factor this top, I'm going to get x plus 4 times x minus 1 all over x minus 1. And when I get that, I'm going to end up with x plus 4 because these two things cancel each other out. That means that I do have a hole, and the hole that I have is at x is 1, and then to find out what that is, I just plug 1 into this leftover function that I have, and I get 5. So I have a hole at the point 1 comma 5. Then I'm looking for my vertical asymptote. So the vertical asymptote in this case is going to be x. Oh, there is none. Sorry, there is no vertical asymptote because I don't have anything in the denominator in this final equation. And then I look to see if I have a horizontal asymptote. So I had x to the second power over x to the first power, top heavy, so no horizontal asymptote. If I don't have a horizontal asymptote, I'm looking for a slant asymptote. But I'm looking at like what happens after I factor. So I'm looking at x plus 4. Even though technically I have x to the 0th power in the denominator there, there is no slant asymptote because there's nothing I can actually divide and get a line when I divide. This is a line. X plus 4 is a line. So I don't have a slant asymptote either. So I don't have a horizontal asymptote. I don't have a vertical asymptote. I don't have a horizontal asymptote. And I don't have a slant asymptote. And so what my graph is going to look like is just a line. I know y equals x plus 4 looks like a line, but I have to be careful because I have a hole. So there's a hole at 1, 5, 1, 2, 3, 4, 5 right here. And then I forgot my important points. My y-intercept is 4, or 0, 4. And my x-intercept, or my 0, is at negative 4, 0. That's the number. Yeah, negative 4, 0. So negative 4, 0, and 0, 4. And then I connect these, and that is my graph.